warahmatullahi wabarakatuh and have a good day everyone. Today I would like to presenting volumetric analysis to determine the purity of acetyl salicylic acid in aspirin. Begin the presentation, I would like to introduce my group members, which is I will go first. I'm Aino Atira. My next members is Nur Sabrina Sakina, Mas Liza, Nur Afika, and the last one is Siti Khadija. Alright, so let's begin. What is volumetric analysis? Volumetric analysis is quantitative chemical analysis in which the amount of substance is determined by the measurement of the volume that the substance occupies. Volumetric analysis is commonly used to determine the unknown concentration of a known reactant. Volumetric analysis is often referred to as a titration, where one substance of known concentration and volume is used to react with another substance of unknown concentration.
I will talk about application related to the topic. First, titration have to find out how much active ingredient is in a drug. This is important to make sure the drug is safe, pure, and has the right amount of medicine. Titration works by mixing two substances, the one we test called analyte and a known one called titrant. We know the reaction is done when we see a color change or a pH change. There are four types of titration commonly used in drug: acid-base titration for drugs like aspirin, redox titration for vitamin like vitamin C, complex geometry titration to check metal ion like calcium, and lastly, precipitation titration for iron like chloride in IV fluid. So, titration is very useful to make sure medicine are made the right way, and in this simulation, we use acid-base titration.
Now, let's take a look at the definition of acid-base titration. Acid-base titration is a quantitative analytical method. This means it is used to measure and calculate specific amounts during a chemical reaction. In this process, an acid reacts with a base to help us to determine the concentration of an unknown substance. We do this by carefully measuring the volume of one solution, usually the titrant that is needed to completely neutralize the other solution. This technique is widely used in chemistry labs to find out how strong or concentrated a solution is. As stated by Peer in 2019, it is a reliable way to gather precise chemical information. The objective of our experiment is to determine the purity of acetyl salicylic acid, which is the active ingredient in aspirin. The chemical formula for acetyl salicylic acid is C9H8O4. We will use the method of acid-base titration to analyze aspirin tablets and find out how much the actual active ingredient they contain. This helps us to assess whether the aspirin tablets meet the expected purity standards.
Next, for chemical equation of titrations, we will combine weak acid with strong base. For these equations, we have acetyl salicylic acid, which act as weak acid, and then we will combine it with sodium hydroxide, which is strong base, and then it will produce sodium salicylate with water. Next, we will be explaining about methodology. For the first one, we have preparation of solution. The sodium hydroxide solution was prepared with 1 gram of sodium hydroxide dissolved in 50 ml of distilled water. Then for the next one, we have preparation of aspirin solution. An aspirin tablet was weighed 1.5 gram accurately using an analytical balance. The tablet then were crushed using a mortar and pestle and then transferred into a 100 ml beaker. And then 25 ml of ethanol was added to dissolve the ASA. And then the solution was stirred well to ensure complete dissolution of the active ingredient.
Alright, for the next procedure is standardization of NaOH solution. The first step is the burette was rinsed with 0.1 m NaOH. Then 20 ml of the HCl was piped into 250 ml conical flask. Then 2 until 3 drops of phenolphthalein indicator was added. HCl in the conical flask was titrated with NaOH from the burette slowly until the indicator color change. For the next is for the determination of acetyl salicylic in aspirin tablet. 10 ml of aspirin solution was pipetted and diluted to the mark with distilled water in 100 ml volumetric flask. 2 ml of the dilute aspirin solution was pipetted into 250 ml conical flask, then 2 and 3 drops of phenolphthalein were added as an indicator. The aspirin in the conical flask was titrated with NaOH from the burette slowly until the indicator color changed to the light pink. The reading of the endpoint of the titration was correct. So this is the example of the result determination acetyl salicylic acid in aspirin tablet. So we got the average volume of NaOH, which is 21.50 ml.
To determine the percentage purity of an aspirin tablet, a titration method was used involving sodium hydroxide NaOH. First, the volume of NaOH used during the titration was measured as 21.50 ml, which is equivalent to 21.50 times 10 power of negative 3 liter. With the concentration of NaOH known to be 0.1 mol per liter, the number of moles of NaOH was calculated using the formula moles equal to volume multiplied by the concentration. This gave 0.00215 mol. Since aspirin reacts with NaOH in a 1 molar ratio, the number of moles of aspirin present was also 0.00215 mol. Using the molar mass of aspirin, which is 180.16 gram per mol, the mass of pure aspirin in the tablet was found by the multiplying the moles by the molar mass, resulting in 0.39 gram of pure aspirin. Finally, the percentage purity of the tablet was calculated by dividing the mass of pure aspirin by the total mass of the aspirin tablet, which is 1.5 gram, and multiplying by 100. The resulting purity was 26%, indicating that only about a quarter of the tablet consists of pure aspirin, while the remainder may be binders or other substance. To conclude, the determination of the purity of acetyl salicylic acid in aspirin tablet is essential for ensuring the quality, safety, and effectiveness of pharmaceutical products. Acetyl salicylic acid is the key active ingredient responsible for aspirin's therapeutic effects, and its accurate dosage is critical in achieving desired medical outcomes. Through analytical techniques such as acid-base titration, the actual amount of pure acetyl salicylic acid in a commercial tablet can be measured and compared to the label amount. This process not only confirms the tablet's compliance with the pharmaceutical standards, but also helps detect degradation, contamination, or the presence of excess filters. Overall, the determination of purity in aspirin tablets serves as a crucial step in quality control, safeguarding consumer health and maintaining trust in pharmaceutical manufacturing. That's all from us. Bye!